Hello everyone, this is my presentation on Arctic sea ice, the system. So let's get into it. So this is the first diagram I made, and as you can see here, it all starts when sunlight enters the atmosphere. Some things reflect sunlight, some things absorb sunlight based on their level of albedo, or how well they absorb or reflect sunlight. Lighter things such as snow, clouds, or ice sheets reflect sunlight really well, which cools the local temperature around them. And on a global scale, this will decrease the global temperature. The opposite can be said for the ocean and land, which are generally dark colored, which absorb sunlight a lot better, heating the local air around them. But again, on a global scale, this will increase the global temperature. And on the inside there, you see that there is a kind of a system between the ocean and ice sheets as well. I'll get into that in more depth later. But the main idea is just this system is balancing and it is stable for the most part. It is pretty basic, but it makes sense. In the past, there's been a little bit of fluctuation with global temperature. There's been ice ages and that kind of thing. But it is relatively stable. But this is my second diagram where you take into account for the greenhouse gases emitted by human activity such as carbon dioxide or methane from industrial agriculture, deforestation, and fossil fuel burning. And I'm sure, as you all know, this causes what is called the greenhouse gas effect, which traps heat inside of Earth's atmosphere significantly better than just clouds can. And this significantly increases the rate at which the global temperature is increasing a lot faster than high albedo things such as ice sheets, snow, and clouds can cool the globe, which is a problem. Now, this is going to have a lot of impacts changing the global temperature. Increasing it is going to have a lot of impacts on this system here on the left, particularly between the ocean and ice sheets. And this causes something called Arctic amplification, which is when, because of the warmer temperature in the Arctic, ice sheets are melting faster than the ocean freezes into ice sheets. So more and more ocean is melted. And as we know, ocean is darker and it absorbs sunlight a lot better than it reflects it, which warms up the local temperature even more, melting more ice into more ocean, warming up the temperature more, melting more ice, revealing more ocean, absorbing more heat, increasing the local temperature. Again, that's called Arctic amplification, and that's really why the Arctic is having such a vast kind of a change in environment. That's why global warming is having such a bigger impact on that area than anywhere else. Is mainly because of Arctic amplification, and this is a very unstable system, and we're nearly past the tipping point. But why is this bad? Well, for one, and I forgot to include it on here, um, uh, Arctic habitats are fastly deteriorating. So polar bears, penguins, seals, they're all really having a tough time right now. They're all endangered. And again, as I also said, this perpetuates global warming on a global scale as well as local. And it is a really big component in global warming and how fast the Earth is heating. This also causes coastal erosion, mainly within the Arctic Circle. One, because it stirs up a lot of storms. The melting of ice stirs up a lot of storms. But two, the ice sheets absorb a lot of the impact of the waves in that area. But the absence of them is causing a lot worse coastal erosion than normal along the Arctic Sea. This also causes more frequent and severe polar vortexes to the south, especially during the winter. We do feel a little bit of the impact even here in the Midwest, but mainly it's worse for people further up north. And the melting of Arctic ice also opens up new routes for trade and tourism. And in an economic point of view, this is a good thing, but remember that this also causes more boat traffic along the Arctic, which poses many risks. It disrupts already endangered environments, and also oil spills and other catastrophes could happen, further damaging the already damaged environments, which is quite a bad thing. Um, and this also accelerates permafrost thaw, which releases a lot of methane into the atmosphere, which is a greenhouse gas. One of the worst ones, is a lot worse than carbon dioxide, further accelerating the rate at which Earth is heating. So what can we do to fix this solution? Well, looking back on the diagram with greenhouse gas, obviously just stop emitting greenhouse gas, try to stop the greenhouse gas effect, which means net zero emissions. So switching to fully renewable energy, no fossil fuel usage. That's a big one. Changing the way our agriculture system works to feed the growing population. That's another really huge one. And also sustainably foresting and preserving the environments around the world, especially forests. That's the best option I can think of. But there's also another solution I thought I'd put in here, where you artificially increase the albedo of the Arctic. This can be done in a few ways, but basically it would involve putting some kind of light-colored object on top of the ocean waves. So maybe like kind of hexagonal tiles that float along the top of the waves, reflecting more light, reducing the rate at which that area is heating. This kind of has its own set of environmental impacts, though. What it has on the local wildlife, and the amount of sunlight that any plants underneath the surface of the water can get. But it is a solution on its own. But yeah, that was my presentation. Thank you guys for watching so much. Have a good day.